Hello. So today we are going to talk about rational numbers and how to write a fraction into a decimal form. So first of all, let's talk about some numbers. So we have 1, 2, 3, 4, this kind of counting numbers, and these numbers are called natural numbers. Okay, natural numbers. And then including natural numbers, so not outside of natural numbers, so including 1, 2, 3, 4. Now we are going to expand this to 0, -1, -2, so on and so forth. And all of these numbers, again, all together. So 1, 2, 3, 4, etc., etc., 0, -1, -2, -3, -4. All those numbers together, we're going to call them integers. Okay, integers. And then we are still missing some numbers we learned before. So for example, I'm not talking about a half yet. I'm not talking about 0.5 yet. I'm not talking about 0.3 yet. I'm not talking about -1.5, this kind of numbers. By the way, you should have noticed a half is same as 0.5. And also, we learned some other kind of numbers such as 0.11111, which repeats forever, or 1.141414, again it repeats forever. And all of these numbers, again including natural numbers, including integers, and including these fractions and decimals, we are going to call them rational numbers. Okay, rational numbers. So if you notice the pattern, so the rational numbers have two forms. So first of all, either it's written in a fraction form or in a decimal form. And when it's in decimal form, again, it has two patterns, two types. So one type is a number ends like 0.5, 0.3, -1.5. And the other case is 0.11111, it goes forever, or 1.141414, it goes forever. And also we can clearly see the pattern. So in 0.11111 case, it's just 11111. If you ask me what comes next, 1. What comes next, 1. In case of 1.141414 case, after 141414, what comes next? 1. What comes next? 4. So clearly I can tell the pattern. So in such cases, we say that the number is a rational number. Okay? Then, now we know what numbers are rational numbers. But the thing is, sometimes when you're given a fraction, we don't know how to show that fraction in decimal form. So now we are going to see how to do it. So the method I gonna show you in this video is we are gonna use long division to convert a fraction into a decimal. Okay, so let's think about this division. Okay, so 10 divided by 3 is, in terms of fraction, that's same as 10 over 3 first of all. Okay, so 10 over 3. This 10 is called the dividend, by the way. You don't have to memorize, but it's good to know. And that 3 is called divisor. Okay? And the number we are going to get on the top here is going to be called the quotient. Quotient. I misspelled there. Okay, quotient. Okay? So this fraction 10 over 3, I want to know how it will look like in decimal form. To find out, I'm going to use the long division. Okay, so let's see what happens. So first of all, here, this 3 cannot go to this digit, this tens digit here, because even though you put the smallest tens digit number, for example, 1, we're going to multiply that number by this divisor. So 10 times 3 is 30. And the rule of this division, long division, is this number should not exceed that number on the top. Okay? So 30 already exceeds 10, so we cannot multiply 10 to 3, right? So we need to go to the next digit. So next digit is here, the ones digit. So now we need to figure out what one-digit number I can multiply to 3. So it's going to be closest to 10, but not exceeding it. So if you think about the multiplication table, you will figure out 3 times 3 gives us the closest number to 10, but not exceeding it, which is 9, right? So now we do 10 minus 9, and 10 minus 9 is 1. And in elementary school, when you first learned the long division, we stopped it here. We just say that 3 is the answer with a quotient, and 1 is the remainder. But since now we are looking for the decimal form of a fraction, we are not going to stop it here. When we are going to stop is either we figure out it terminates or it repeats, and clearly we can see the pattern. So until we see the result, which is if it's the terminates or repeats, we are going to continue this process, okay? So now we are going to divide 1 by 3. And to divide 1 by 3, I'm going to use the decimal point and the 10th digit here. So imagine if I put 1 here, for example, that's going to be 0.1, and 0.1 times 3 will be 0.3. This number is still less than 1, but we can do better. We can get closer to that 1, which is we can use 0.3. Then 3 times 0.3 is going to be 0.9. Again, we subtract. 1 minus 0.9 is going to be 0.1. Then we repeat the same process. Then 3 times 0.01 will be 0.03. But we can do better than that, again, by assigning 3 to the 100th digit number, which means 0.01 times 3 will be 0.09. Then next is going to be 0.01. But at this point, we can logically guess or conclude that this will repeat. So every time I'm going to get one digit less number, which is 1, 0.01, 0.001, 0.001, and every time I'm going to just multiply 3 to the next digit here, which we can conclude that this 333 will repeat. So now our conclusion is 10 over 3 will be 3.3333. It repeats forever. Or another way to say that is 3.3 and a bar on the top. Okay? So let's look at the next example. So next example is 1 divided by 8. So which means in terms of fraction, this is 1 over 8. Okay? So let's see if it repeats or it terminates. So first, obviously we cannot put 1 here because if I put 1 there, it's going to be 8 times 1 is 8, which exceeds 1. So we cannot use the 1's digit. Let's go to the 10th digit here. So if I put 0.1, then 0.1 times 8 is 0.8. And this is a good start because if I put 2, it's going to be 1.6. It's going to be larger than 1. So we need to start here. 1 minus 0.8 is 0.2. So now I'm going to use the 100th digit. If I put 1 in the 100th digit, that's going to be 0.08, which is less than 0.2, but we can do better than that by assigning 2 here. Then 0.02 times 8 is 0.16. Then 0.2 minus 0.16 is 0.04. Now we are going to use the thousandth digit. In thousandth digit, if I put 1 here, it's going to be 0.008. And from this 8 to that 4, it's like same as 40 and 8, right? Then what kind of number can you multiply to 8? It should be 0.005. So if I multiply 0.005 to 8, it's going to be 0.04. And 0.04 minus 0.04 is 0. So we figured out that it terminates. It terminates at 0.125. So 1 over 8, this rational number, we can write it as 0.125. Okay? Here's the next example. Let's divide 1 by 7 this time. So again, in terms of fraction, this is same as 1 over 7. So I want to find out how 1 over 7 looks like as a decimal. So first, again, we cannot use ones digit, so we need to go to tenth digit. Let's put 0.1 here. Then it's gonna be 0.7, and we are gonna do 1 minus 0.7, which is 0.3. So now we are gonna use hundredth digit. Again, this hundredth digit goes to here. So if I put 1 in the hundredth digit, it's gonna be 0.07, but I can get closer to 0.3 by assigning, in this case, 4. Because 7 times 4 is 28. So if I do 0.04 times 7, that's going to be 0.28. So 0.3 minus 0.28 is going to be 0.02. So now we are going to thousands digit. So if I put 1 here, that's going to be 7 here, right? So let's assign 2, because then it's going to be 0.014. Obviously, we cannot put 3. If we put 3 there, it's going to be 0.021, which exceeds 0.02. So now if I subtract the bottom line, it's going to be 0.005, not 5, 6. Okay. So now our next digit goes to here. And which number should we multiply to 7 this time? It's going to be 8. So if we put 8 here, it's going to be 0.0056, because 7 times 8 is 56. Then once again we subtract, it's going to be 0.0004. Then now next number is going to be 5, which is 0.00035, and subtract again. Then it's going to be 0.00005. The next number will be 7. Let's make it bigger here. Then it's going to be 0.00049. And now next is 0.00001. And at this point, we saw the number which is the same as the original dividend. So if you're curious when we should stop exactly, when we see after this kind of subtraction, at some point, if you see a number that is exactly same as our original dividend, okay, then that's the point we stop, and we can logically guess the same thing will happen from the next digit again. So after 0.142857, I know next number is going to be 1, I know next number is going to be 4, I know the next number is going to be 2, so we know that 0.142857, this 142857 part will repeat. So we can find out that the fraction 1 over 7 is same as 0.142857, which repeats. Okay. And let's go to the last example today. So in this case, we have decimal and decimal in both dividend and divisor. So one way is, if you are familiar with dealing in the decimals, you can just directly do the division, same as other questions. One method I suggest if you are confused dealing with the decimals is first make the divisor an integer, okay? Then how do we do that? So first let's think about this fraction, okay? So this as a fraction is 1.2 over 0.5, okay? So now, of course, I can multiply other numbers. In this case, 2 looks good too, but just in general, you can multiply 10, 100, 1000 kind of numbers. So 10 to the power of something kind of numbers. So in this case, I can multiply 10 over 10. Okay, 10 over 10. Then this will be same as 12 over 5, right? So instead of doing 1.2 divided by 0.5, I suggest you to do 12 divided by 5, okay? I suggest this method. And then, okay, so if you do this way, so the good thing is now we have integers. So when you multiply this quotient part by the divisor part, sometimes when you have decimal at that point, it's gonna be more complicated than usual. So this will simplify your calculation sometimes. So I suggest this way. So let's do it then. So 5 times 2 will be 10. So 12 minus 10 is 2. So now we need to go to 10th digit. And in 10th digit, we need 4, such that 0.4 times 5 will be 2. And now 2 minus 2 is 0. So we can find out that this is a terminating number. And 1.2 over 0.5, which is 12 over 5, is same as 2.4. Then that's the decimal representation of this fraction 12 over 5. Okay, so today we learned how to use long division to convert fractional form of a rational number into decimal form of a rational number. Okay, so please do the homework and see you next time.